In exercise 6b, the focus becomes a GP because it's the presence of a GP in some investment situations that becomes our real focus here on finance. So, given that the GP is of the format to find a term in a GP, A times R to the n minus 1, and n being a variable, if you're asked to calculate that variable, find that variable, you're solving for an exponent. You're solving for a power. Then that's where logs are really useful, because you know the definition of a log. The log of a number to a given base is the power to which the base has to be raised in order to give this number. So we're going to see now a combination of logs and series in order to answer particular questions. The textbook does indicate that you could find a power by using trial and error, which is true, but as it says there, it's very time consuming and it's not that accurate. And if you want me to do an example on trial and error, please make sure you ask. Otherwise I'll assume that you would know to guess a number, sub it into the formula for n, do the calculation, see how close you get, and then adjust your guess either up or down based on the conclusion from your first guess, and just keep going in that manner until you get as close as they're asking you to get with your trial and error method. Otherwise, I'm going to go straight to logs, so I'm not going to be using trial and error. So in this example, it says show that 10, 11, 12.1, etc. is a geometric sequence. We know that our GP has to have a common ratio, and the common ratio being t of n plus 1, the n plus 1th term over the term before that. So I've set up the second term over the first term. Now 11 on 10 as a fraction we probably don't have an extensive understanding of, but 11 on 10 is 1.1 as a decimal. And then you could see by the calculator that the third term over the second term, this 12.1 divided by 11, is also 1.1. That's sufficient to say, therefore, the sequence is geometric. And move on to B. State the first term and the common ratio. Well, we've done that. A is equal to 10 and R is equal to 1.1. C, use the formula to write down the 15th term. So the 15th term is A times R is 1.1 and to the n minus 1, which is 14. And as you can see there, that's 37.9749, etc. Any instruction? Okay. I'll just write it to 2dp, 37.97. Okay, D is by far the more common style of question you'll get. It says, find the number of terms. Obviously, n is the power. We're finding the n. We're solving for a power. We use logs. For find the number of terms less than 60. So how many terms would there be before we get up to 60. What we're going to solve, and what I would strongly encourage you to do in every situation like this, is find the term that would be 60. Now, it's pretty likely that it'll be an unrealistic term, but let's set about finding the term that actually equals 60. So we are saying Tn is 60. How do you get Tn? Well, Tn is 10 times 1.1 to the n minus 1. Therefore, we've got that 60 is 10 times 1.1 to the n minus 1. A bit more room over here, so I'll go there. Divide both sides by 10, and so we've got that 6 is equal to 1.1 to the n minus 1. Now, remember, what this is going to give us is the nth term that is actually 60. So I'm wanting the power to which this base is raised in order to give this number. So if I take the log of that number to this base, it gives me the power to which that base needed to be raised in order to get that number. I can't do this on my calculator without doing a change of base. So it's log of 6 divided by log of 1.1, and that would be equal to n minus 1, and I'm going to bring the 1 over. Okay, just a couple of things about the calculator and just things to be aware of and be careful, especially with this new calculator. So I used the fraction button, and that closed bracket on the top of the fraction didn't actually appear. I had to put it in, and the same on the denominator of the fraction. The closed bracket didn't appear. But please put them in, otherwise I'm pretty confident that you will get an error, or you're very likely to get an error. So what we've done, what you've been able to see there, is that the 60th, you will get 60 at this unrealistic term. We never talk about the 19.799th term. We either talk about the 19th term or the 20th term. So we've got that n is equal to 19.79. So how do we interpret that? We say that the 19th term was obviously something less than 60. This unrealistic term that never really happened was a 60. The 20th term, which would be the next realistic term, would be something bigger than 60. So at 19, we've got terms that are less than 60. The question said, find the number of terms less than 60. So therefore, there are 19 terms less than 60. So can you see that it is fine to solve your equation with an equal sign, which negates the difficulties with an inequality? Then stop and think about what you've found, compare it to what the question asked, and then you'll know whether you either round up or round your answer down.